Okay, this is the amplifiers chapter, and in it we're asked to compute the input resistance of a couple of circuits. So this is the first one. If you notice, the base emitter resistance R pi, which is the small signal equivalent for this transistor, is in parallel with R2, as the emitter is at ground and the bases are at the same potential. So part of this resistance or input resistance is seen looking in from the base is going to be R2 in parallel with R pi. Once we combine these into one resistance, we see that R1 is in series with them. So the total resistance is R1 plus R2 in parallel with R pi. And R pi is small, it comes from small signal parameters beta and GM, and this is the formula for GM, although it's not needed. So the second circuit looks like this, except the base is grounded and we're looking into the emitter. And that's important because when we look in from the emitter, we see a resistance of 1 over GM or transconductance. And we have this external emitter resistor right here, R1. So looking at this and R pi, the base emitter resistance, we see that once again, from a small signal perspective, they're in parallel. So part of our resistance will for sure be R1 in parallel with R pi. And it's hard to see, but looking in from the emitter, 1 over GM is also in parallel with those two impedances. So our total input resistance as seen from the emitter is this expression right here.